Alright, so again guys, I'm going to preface this with the fact that I am watching my son right now and he is literally sleeping right next to my iPad. So if he wakes up, I apologize. I will pause and try to get him settled before I continue the video. So here's 2-4, deductive reasoning. So far we've only been using inductive reasoning. So here we need to identify the hypothesis and conclusion. Don't need to solve it. We already know that x is equal to 4, so hopefully, anyway. But it doesn't matter. We're not trying to decide if it's valid or not. So remember, hypothesis goes with the if, conclusion goes with the then. So this is just a hypothesis and conclusion. Our second one is not an if-then form, but it does have an if in it. So if it has 6 sides, that's our hypothesis. It has 6 sides. Conclusion is that it's a hexagon. Okay, so now let's move on to our notes. So here we're just going to look at deductive reasoning. Valid, Law of Detachment, and the Law of Syllogism. So those are our 4 vocab words we're covering today. These are pretty short notes, so probably be done with these pretty quickly. So, first thing we need to do, example 1, is determine whether a conclusion is based on inductive or deductive reasoning. So inductive reasoning is what we've been doing. It's based on patterns. Deductive reasoning is based on facts, laws, theorems, postulates, definitions, things like that. So in Miguel's town, the month of April has had the most rain for the past 5 years. He thinks that April will have the most rain this year. He is using a pattern, right? Every month of April, it's been the most rainy, so that means he thinks it's going to continue that pattern. So this is inductive reasoning. Next one, Sandra learned that if it is cloudy at night, it will not be as cold in the morning than if there were no clouds at night. Sandra knows it will be cloudy tonight, so she believes it will not be cold tomorrow morning. So she is not using a pattern, she is using a fact that she learned. So that means this is deductive reasoning. Alright, so moving on to example 2. Well, after our definition of law of detachment. So the law of detachment says that if P then Q is a true statement, and we know the hypothesis is true, then the conclusion is also true. So here we're given that if a car is out of gas, then it will not start. That's true. Cars won't start if they're out of gas. Sarah's car is out of gas, so now we can conclude that the car will not start. We can't go the other way with it. We can't say if a car is out of gas, then it will not start. Sarah's car will not start. We can't conclude that it's out of gas because there could be other things wrong with their car, right? So we have to make sure that it is P that is the true part, not Q. So here's an example. If a figure is a square, then it is a parallelogram. So squares are parallelograms, so that is a true conditional. So if P, then Q is true. Okay. And then the last part, the figure is a parallelogram. Okay. Can we conclude that the figure is a square? So our P then Q statement, we're given the Q part being true, not P. That's not okay. This is invalid. We can't say Q is true, right? All squares are parallelograms. But not all parallelograms are squares. We got rectangles, we got rhombi, just regular old parallelograms, right? So that is an invalid argument. Okay, next one here, same idea, but now we have a Venn diagram given to us. So if a triangle is equilateral, then it is an acute triangle. Remember earlier we said that equilateral triangles all have 60-degree angles. 60 degrees is an acute angle, so that means this is true. And the triangle is equilateral, which is our P portion of our statement. So that means that we can conclude Q is true, and this conclusion here is Q, so this is valid. So we're good to go. The next one here, and yet rectangles and squares. So again, if a figure is a square, then it has 4 right angles. That's true. Squares do have 4 equal sides and 4 equal angles. A figure has 4 right angles. Okay, so that is the second half of our first statement, not the first half. We can't conclude it's a square. So this is invalid, again. Rectangles, right? Rectangles also have 4 right angles. So it's invalid because of rectangles. So now the law of syllogism. This one is similar to what we'll learn later is the transitive property. So if P then Q, and if P then Q, and if Q then R are true statements, then you can eliminate Q and just say that if P then R is a true statement. So if you get a job, then you will earn money. If you earn money, then you will buy a car. So we gonna pause the video. Okay, sorry about that. I know my child's cry just suddenly stopped, but he's taken care of now. He's alright. He's getting fed. So I'm going to finish this video up. So anyway, like I said, we basically remove the middleman. So you will earn money doesn't need to be said twice. So if you get a job, then you will buy a car. So let's look at some examples of this. So we need to determine the statement that follows logically. And again, the dog over here. Get out, man. All kinds of interruptions for this video. Told my dog I didn't want her in the room, and she came in here anyway. So we're going to combine these two statements together into one statement, if we can. So if Jamal finishes his homework, he'll go out with his friends. That's statement number 1. Statement number 2, if Jamal goes out with his friends, he will go to the movies. So if you notice, he'll go out with his friends is on there twice. So we can eliminate that portion and just leave the things that are outside of that part. So we can use the hypothesis from the first one. If Jamal finishes his homework, this is 3. If Jamal finishes his homework, then he'll go to the movies. Okay, so we eliminated the going out with his friends part because that's going to happen. If the first thing happens, then the second thing is going to for sure happen, and that means the third thing will happen. Okay, one more example. So here again, law of syllogism. If your alarm clock goes off in the morning, then you'll get out of bed. If you ride a bus, then you go to work. None of these are common, right? So we can't create a new statement from these, eliminating the common part. So this is invalid. And that's all there is to it. We can't combine anything together. Can't say if your alarm clock goes off in the morning, then you'll go to work, because we don't know if you get out of bed and you ride the bus. Okay, so again, we had some practice problems to do. Here's our exit ticket. We're going to combine things together again, and if we combine them together right, then they should be number 3 if that's what happens. We could be looking at Law of Detachment here. So, if a children's movie is playing on Saturday, Janine will take her little sister Jill to the movie. Janine always buys Jill popcorn at the movies. So statement 3 says if a children's movie is playing on Saturday, Jill will get popcorn. And so we're taking out the whole going to the movies part. They're taking her little sister to the movies and saying that they go to the movies, or the children's movie's playing and they get popcorn. So that is law of syllogism, and this is valid. Okay, and that is it for this video. That's all for the notes and the exit ticket, warm up, all that is done. So, I'll see you on Monday making more videos.